So what do we have? So when we basically have this Lens-Snickers formula, right? See, why do we use this formula? When we are dealing with the Lens-Snickers formula, what exactly does that mean? Just understand. When we are using this Lens-Snickers formula, right? This basically means this basically means what? That we have to construct a lens. All right. Now, when we have to construct a lens, what exactly does that mean? That simply means that whenever we have to construct this formula or whenever we have to construct this uh, lens, I told you how lenses are actually formed, right? Let's say I will take a sphere and I will take another sphere. So we will have sphere 1 and we'll have sphere 2. Once I have sphere 1 and once I have sphere 2, what do? I basically have this sphere and I cut a half part of it. I have another sphere
Mm.
and I cut another half part of it. I take this part of the sphere and I take this part of the sphere. And once I have this part of the sphere and once I have another part of the sphere, I'll join them together. And hence I'm going to make a lens of a certain wavelength, of a certain focal length. Yes or no? So do we understand that this middle portion is called as the optical center?
Yeah.
So what do we have? So we have the sphere 2 and we have the sphere 1. So when we have this, so every sphere has a center of curvature. So you understand, you are measuring it towards right. This is radius of curvature 1. You are measuring it towards, this is center of curvature 2. This is R2. Yes or no? So when we have R1 and when we have R2, what does that mean? When we have R1 and when we have R2, what does that mean? Just tell me.
R1
That
is the
whenever we
radius
have
of the
R1 and whenever
first
we have
circle.
R2, yeah, we have this. So what does that mean? It would simply mean that R1 and R2 we have. So R1, whenever you measure, is always towards the right, and R1 is thereby always taken to be positive. What is R1? It is the radius of that sphere from which this side of the lens, the black side of the lens, has been cut out. What is R2? It is that side of the lens from which R2 shall be cut out, and that shall be negative. Are we understanding my point? R1 will be positive and R2 here shall be negative.
Negative.
Got the point? So R1 here is going to be positive and R2 here is going to be negative, right? So that's the basic idea. So when we are dealing with the lens maker's formula, what exactly does that mean, right? So sometimes we have certain lenses that, see, normally if you look at this lens, you see that both the spheres that we're using are exactly identical. Whatever is the radius of this circle, the same we have the radius of the other circle. Yes or no? The same we have this. But sometimes there's a highly likely possibility that we have one sphere like this and one is a bigger circle. Then what would that mean? If I have a bigger circle like this, so one is a smaller circle and one is a bigger circle.
Right.
So this is my center and this is also my center. So what does that mean? Tell me.
The bigger circle's radius is longer.
So now this part you see, this is a little flattened side. This is a little flattened side. Yes or no? And if this is a little flattened side, it would mean what? And this side of it would be what? This is a smaller sphere. So whichever is a smaller sphere will seem to be more curved. Whichever is a smaller sphere seems to be more curved. Are we understanding my point?
Mm-hmm.
And whichever seems to be flattened sphere seems to be a bigger sphere. That's a part of the lens coming from the bigger sphere. Are we understanding my point or not?
Yeah.
So there is a chance that we might have a lens like that. We might have a lens like that. So this is not an equiconvex lens, no. But this is going to make a equiconvex. So yes or no? So we will have an equiconvex lens. Got the point?
Yeah.
Any doubts on this? Got the point? Got it? So we will have an equiconvex lens, and this is not an equiconvex lens. So this is simply different. Now, if I have to make a lens like this, but my requirement is that for every lens, I need to know the focal length. So for this lens, the focal length can be 20 centimeters. For the other lens, the focal length can be 30 centimeters. Yes or no? For
Yeah.
different lenses, the focal length can be this value. So the point here is what? So we have a lens maker's formula. Now, lens maker's formula can be applied to what? This is 1 by f. Here is going to be n minus 1 into 1 by r1 minus 1 by r2. And that is my lens maker's formula. You understand my point? So
Yeah.
n here is my refractive index. How? When the light is moving from outer medium 1 to 2. This is the lens medium is 2. So I would write it as 1 to 2. That means light is moving from medium 1 to medium 2. Remember this arrow. Remember this arrow. The light is moving from medium 1 to medium 2. Got the point? So 1 by f here is equals to n minus 1 into 1 by r1 minus 1 by r2. And this is going to be the value that we have. Got the point? So this is my
Mm-hmm.
lens maker's formula. Now, how do I apply to this question? Now, let's see. Now, whatever matters, sometimes the lens is placed in air. Sometimes the lens is placed in air. So obviously, refractive index of air is what? Always remember the refractive index of air is considered to be 1. Sometimes the lens is placed in water. The lens is placed in water. The refractive index of water is 1.5, 1.33. The refractive index of water is 1.33. Got the point or no? The refractive index of water is 1.33. The refractive index of glass is 1.5. How we
Mm-hmm.
understand? So we
Yeah.
have this. So this is the refractive index, and the lens is kind of placed in air. So that's my lens maker's formula, and the value here is going to be 1 by f. Here is going to be equals to n minus 1 into 1 by r1 minus 1 by r2. All right.
Yeah.
So that's the value. Now understand. So when we have the multiple questions, the question says what? My first question says there is a convex lens. The convex lens is dipped in a liquid whose refractive index is equal to the refractive index of the lens. whose refractive index is equal to the refractive index of the lens. What shall be the focal length? What will be the focal length of the lens? So you understand what is the situation. There is this container, and then there is this lens, and then there is this water. Yes or no? So I hope you're understanding that whenever we are dealing with a convex lens and it is dipped in a liquid, it is dipped in a liquid. So what does that mean? So light is entering from water to glass. And what does it say? Whatever the liquid we have, the same refractive index of the glass is there. Because obviously the lens is made up of glass. So what is the formula? 1 by focal length is what? Right? Is equals to n minus 1 into 1 by r1 minus 1 by r2. And unless and until anything is mentioned to me, I do not know whether R1 is equals to R2 or whether R1 is not equals to R2. I cannot make a decision on that.
Mm-hmm.
So 1 by F is n minus 1 into 1 by R1 minus 1 by R2. Yes or no? So what are we doing? 1 by focal length is what? This is medium 1 to 2. Outer one is medium 1. Inner one is medium 2. So I'm going to write n12 is going to be n2 by n1. That is going to be n2 by n1. That's n2 by n1 minus 1 into 1 by r1 minus 1 by r2. Are we understanding, Aaron? How do
Yeah.
I elaborate this part? Do you understand? 1 and 2. How do I elaborate this part? N2 by N1 or not?
Mm-hmm.
Right? Now, both of them are equal. N1 is equal to N2. How do I get to know? It says a convex lens is dipped in a liquid whose refractive index is equal to the refractive index of the lens. The liquid's refractive index is equal to the refractive index of the lens. Are we understanding? So 1 by focal length is going to be
Mm-hmm.
1 minus 1 into 1 by R1 minus 1 by R2. This value comes out to be 0.
Yeah.
And hence everything comes out to be 0. So 1 by focal length, if it is 0, the focal length here will be 1 by 0, which is nothing but what? Infinity. Yes or no? That means what is infinity? That means if this is the liquid and the lens is placed here, and this is the liquid in which this lens is actually placed. So the light rays, they basically go inside, and outside and inside refractive index is same. That means it behaves like a simple medium. The light rays goes simply straight. Are we understanding my point? So if light
Mm-hmm.
rays goes exactly straight, if light rays goes exactly straight, that means it behaves like a simple glass. And this lens in a liquid, where the refractive index of the liquid is
Yeah.
equal to the refractive index of the lens, if they are equal. You understand? Refractive index of the liquid is equal to the refractive index of the lens. Then the lens becomes invisible. Are we understanding?
Yeah.
Got the point?
Mm-hmm.
Got the point or no? Yes or no? The light rays, they goes exactly straight, and the lens will thereby become invisible. Yes or no? That's one question. Second question that they're going to ask you is just listen. 1 by 0 becomes infinity. Now it says the focal length, find the focal length.
Mm-hmm.
Question says, find the focal length. See, understand, there are two formulas. For lenses, one we have 1 by V minus 1 by U is 1 by F. In this formula also, you can find out the focal length. The other formula would be 1 by F is n minus 1 into 1 by R1 minus 1 by R2. Now, when you read the question, both of them can be applied to lenses. But whenever you read the question, Look at the data that they're giving. If they're giving you refractive index and the radius of curvature of the two sphere mirrors, of the two spheres from which this lens has been made out, then we have the focal length. So what does it say? It says find the focal length of the lens in air of the glass lens whose mu is equals to nothing but what, 1.5. Find the focal length of the glass lens in air, and the focal length is 20 centimeters. The focal length is given to me. I'm so sorry. Okay. It says if it is dipped in water, if it is dipped in water, if it is dipped in water of mu 4 by 3, if it is dipped in water of mu is equals to 4 by 3, its focal length will be, its focal length will be what value? Now understand. See, the same lens is this. This is one lens. The same lens, if I keep this in air, keeping this lens in air will not change the sphere and will neither change this sphere. Are we understand? If you have this lens and you are keeping this lens in air, it will neither change this sphere and it is neither going to change this sphere. Are we understanding my point?
Yeah.
Yes or no? So the idea here is what? The idea here is this. That ma'am, if I keep this in the same lens, if I keep it in water, then also the sphere is not changing. Then also the sphere is not changing. Are we understanding? What does that mean? That means if I apply, I say the focal length, 1 by focal length in air is refractive index of light is moving from air to glass minus 1. 1 by R1. Any
Yeah.
doubts in this? And the same
No.
with water. Then I'm saying light is moving from water to glass minus 1 and 1 by R1 minus 1 by R2. Are we understanding? Do we read the two statements? Because once we have placed the same lens in water and the same lens is placed in air. I have two conditions according to the question. Once that happens, I'm going to divide it and this part gets cancelled. Are we understanding?
Yeah.
Right? Now, what does it become? It becomes 1 by focal length in air gets divided by 1 by focal length in water. This is equals to what? N. This is equals to what? This is basically going to be equals to N air to glass.
Over
Are we understanding
N
this part?
water to glass.
Got the
Minus
point?
1. Yeah.
So here it is going to be what? F air into F water because the other part gets reciprocated. That is N glass by N air minus 1 divided by N glass by N water minus 1. Are we understanding? Because in terms of
Yeah.
refractive index, the lower portion is written at the top and the top portion is written at the bottom. Are we understanding?
Yeah.
Refractive index of air is 1. So they have already given me the refractive index of glass. So they have given me mu of glass is nothing but what, 1.5? Yes or no? So mu of glass is given to me as 1.5. That is 3 by 2. And refractive index of water is given to me as 4 by 3. Whatever these refractive indices are given to us, beta, they are with regards to air. They are with regards to air. Are we understanding my point?
And A is.
So you put in the values of focal length in water, we have to calculate in air, the focal length is 20 centimeters. Air refractive index is 1. So Ng, I'm going to write it down as 3 by 2 minus 1. Divided by Ng is 3 by 2 divided by Nw, 4 by 3 minus 1. Because Ng, water se light, if the light is entering from water to glass, I am going to write this down as Ng by Nw. Ang, the light is entering from Ng by Nw.
Yeah.
Yes or no? So the other value becomes what? 3 by 2 minus 1 is going to be 1 by 2.
Can't you
This
reciprocate?
becomes 3 by 2 into 3 by 4, so minus 1. So this becomes 9 by 8 minus 1, which is 1 by 8. So the denominator on solving becomes what? This becomes F water by 20 is 1 by 2 divided by 9 by 8 minus 1, which is 1 by 8. So this becomes 1 by 2 into 1 by 8 into 8. That becomes 4. So here what do we get? F water by F20 by 20. F water by 20 is basically 4. So focal length in water becomes what? 80 centimeters. Are we understanding?
Yeah.
So that means what? You understand. If you realize the fact that this is my lens and this is air and this is my refractive index and the light enters, and because air's refractive index is 1 and glass refractive index is 1.5, there's a huge difference between 1 and 1.5. There is a huge difference between 1 and 1.5. Yes or no? Got the point? The light you see it bends more. But when you place the same lens in water, the water's refractive index is 1.33 and glass refractive index is 1.5. So between 1.33 and 1.5, there's a lot of difference. And that difference is how much? How much is that difference? This is 1.5. So when you put the light in, the light doesn't bend much because 1.3 is very close to 1.5. So light feels that there is not a change in the medium at all. And as a result, light doesn't bend at all and goes out. It goes at a far distance. Are we understanding? And when it goes out at a far distance, we meet this point, which is my focal. Are we
Mm-hmm.
understanding it? And wherever the light bends and meets from the optical distance, that is my focal length. So you see here, the light bends
Yeah.
by less amount. Here, the light is bending by a larger angle. You understand? The light has to go straight. It bends by smaller angles. You understand? So when light bends more, that means this was the expected path. The light is come down by a larger angle. When the lens is thin, light goes inside and light doesn't bend much. When the light doesn't bend much from its expected path, this is the theta. Yes or no?
Yeah.
Are we understanding? So where do you think the focal length becomes more? Where the light bends more, then the focal length is more? Or where the light bends to a lesser quantity, then the focal length is more? Tell me. Where is the yes or no?
Yeah.
Are we understanding, Aaron?
Mm-hmm. Yeah.
Where do you find the focal length to be more? Where the light bends by a bigger angle or where the light bends by a smaller angle? Tell me. Tell me. Tell me, Aaron, where is the focal length
Yeah.
more? Tell me, where the light bend, where, what is focal length? From the center to that point where all the rays are meeting.
Yeah.
From center to that point where all rays are meeting. Yes or no?
Yeah.
So from center to that point where all rays are meeting, what does that mean?
Mm-hmm.
Tell me. So from center to that point, this is my focal length. So from here to here, this is also my focal length. Tell me. Where is the focal length more?
Mm-hmm.
Honey, tell me, where is the focal length more? Case A or case B? The top part or the bottom part? Tell me, Aaron.
Yeah.
Where is the focal length more?
The focal length is, yeah, it's more, it's longer
Where? Case A or case B?
in case B.
Case B. So in case B, do you see bending more? Or in case A, do you see the band,
Case
this
A,
theta
there's more
angle?
bending.
Yeah.
Case
So
A,
where?
there's more
So can
bending.
I say there is more bending? Where there is more bending,
The
focal length
focal
is?
length is smaller.
Yeah. Got the point? And
Yeah.
here there is less bending.
Focal length is longer.
Yeah. Focal length is long.
Yeah.
Got the point?
Yeah.
So that's the idea that we have. So when we are dealing with this part, so you understand that focal length in case of water came out to be 80 centimeters long. Understood? Next question.
Yeah.
Now let's have a look at the next question.
Mm-hmm.
What does it mean? Now I'm going to put it here. It says there's a
Yeah.
plane. Next question. Read this. Next question says a plano convex lens. A plano convex lens mu equals to 1.5. Basically, this is the mu of the glass with which the lens is made. Has
Mm-hmm.
a radius of curvature
Yeah.
10 centimeters. Okay. Find its focal. Now, what is this
Mm-hmm.
question? It says we have this lens. Plano means one side is cut part and this is only convex. Got the point?
Mm-hmm.
So the focal length is what? So that means what? Whenever you have this flattened portion, it means it is an infinite circle. It means it is an infinite circle. So
Yeah.
whenever it is an infinite circle, it means what? Whenever it is an infinite circle, it means what? We
Mm.
have this part. And whenever there is an infinite circle, it basically means what? That ma'am, for this radius of curvature 1 is going to be infinity centimeters because it's a huge circle. Got the point.
Mm.
But for the other circle, this value is going to be 10 centimeters. The radius of curvature is 10 centimeters. So I'm going to put the formula 1 by focal length is refractive index of light is entry from air to glass minus 1 into 1 by R1 minus 1 by R. I have to calculate the focal length. The refractive index is given to me as 1.5. So I'm going to write down 1.5 minus 1 because how do I elaborate this? A and G is basically Ng by N. The lower portion's refractive index comes at the top, becomes the numerator, and then this part comes at the bottom and it becomes a denominator. Got the point or no? So we have this. What is
Yeah.
1 by R1? 1 by R1 is infinity minus 1 by R2 minus 10. Why minus 10? Because this is from here measured towards the left. all the distances measured towards the left are said to be negative. I hope there is no exam in this week,
No.
right? Okay. So that's the part. So what do I have? 1 by focal length is what? 0.5 into 1 by infinity is what? Just tell me one very basic example. Just tell me what is 1 by 10? 0.1. What is 1 by 100? 0.01. What is 1 by 1000? 0.0001. 1 by 10,000. 0.0001. Are we understanding?
Yeah.
So we have these values. So the moment you keep on increasing the denominator, these values will tend towards 0. Yes or no? This value will tend towards 0.
Yeah.
So what does that mean? That whenever we have this, so I say that 1 by, so when I say 1 by focal length is what? 1.5
1 by
minus 1.
1.5.
1 by R1 is infinity minus of minus 1 by 10. So this is going to be 0.5 into 0 plus 1 by 10. This is 1 by focal length. So this becomes how much? 1 by focal length is going to be 0.5 by 10, which is 0.05. That's 1 by focal length. Focal length becomes 1 by 0.05. You put 100 here, it becomes 20 centimeters. So my focal length here is going to be equals to 20 centimeters.
Yeah.
Got it? Any doubts in this question?
Mm-hmm.
Got the point
Yeah.
or not?
Yes.
Next question. Next question. Now, what does it mean?
Yeah. Uh, oh.
Any doubts in this question?
Uh-huh. Okay. Yeah. That's the question.
One second. Now calculate. You calculate now. Calculate the focal length of a lens of radius of curvature 10 centimeters and 30 centimeters. And the refractive index of the lens is 1.8. Calculate. And it's a convex lens. It's a convex lens. Equiconvex lens or not equiconvex lens, that you'll have to check. So whether it is an equiconvex lens or not an equiconvex lens. Whether it's an equiconvex lens or not an equiconvex lens. So that you'll have to see. Are we understanding?
Yeah.
Now do it. Solve it. Now, how are we going to put it? We're going to put it into a formula again. 1 by focal length is going to be n minus 1 into
Right.
1 by r1 minus 1 by r2. So 1 by focal length we have to calculate. N minus 1. The refractive
We
index
have
of glass
1.8,
with regards to air. So it is 1.8 minus 1. 1 by
which is
R1.
0.8.
How much is R1? R1 is 10
R1
centimeters. See,
is,
understand. You are subtracting 1 by R2 from 1 by R1. Yes or no?
yeah.
So once you're subtracting 1 by R2 from 1 by R1, that exactly means what? that 1 by R2 is a smaller value.
Bigger value.
1 by R2 should be
Smaller,
smaller.
sorry.
When will 1 by R2 smaller? When R2 is bigger.
Yeah.
You tell me 1 by 2 is bigger or 1 by 10 is bigger. 1 by 2 comes out to be 0.5. 1 by 10 comes out to be 0.1. Yes or no?
Yeah.
So if this value is 0.5 and if this value is 0.1, what does that mean? That 0.5 is there and this is 0.1. Understood?
Yeah.
So what does that mean? It simply means
Uh,
what?
that R1 would be has to be a smaller value than R2 for this to work.
Yes. Got the point or not?
Yeah.
So that's what you have to understand here. That whenever we have this particular part, so 1 by R1 minus 1 by R2, so 1 by R1 has to be a bigger value if you are subtracting. But you understand one more thing, that if you have a lens like this, so this is my R1 and this is my R2. Have you understand? One is my R1 and one is my R2. Any doubts on this?
Mm-hmm.
So when one is R1 and when one is R2, what does that mean? Just tell me. When one is R1 and one is R2, what does that mean?
One is
So I'm going to put 1 by R minus of minus 1 by 30 because one is towards the right we are measuring. So the direction matters here. Towards the
Oh,
right is always taken to be positive.
wait.
One towards the left is always taken to be negative.
Oh, I forgot to do that. Oh no. That's 4 over 15. 2 over 15.
1 by 10 plus 1 by 30. So 1 by focal length is going to be 1 by 8 into how much is that into 3 into 3? So that's going to be 3 by 30. The basic sense here says 1 by focal length is going to be 0.8 into 3 by 30. So you cancel this out, you get 10. So you get 0.08 is nothing but 1
It's
by
not
focal
3
length.
by
So if this
30.
cross, that's
Is it 3 by
0.0.
30?
Yeah.
No, you're doing 1 over 30 plus 3 over 30.
That should be 4 by 30. I'm so sorry. That should be 4 over
Yeah.
30. So that comes out to be how much? That comes out to be 4 over 30. So I'm not going to cancel it. That's going to become 2 over 15, if I'm not wrong. So what does my focal length comes out to be? My focal length comes out to be 15 over 2 into 0.8. So that's going to be 150 over 16. So my focal length here is going to be how much? It's going to be 2 8s are 275. So that's going to be 75 over 8. That's going to be 75
75
over 8.
over
And that's
8.
the answer. Whatever that value comes out to be, that's going to be my answer. Are we understanding?
10.
Any doubts
Yeah.
in this? Just tell me.
No.
Got it? Any doubts?
No.
Sure. Right. So that's how basically things are. That's how things
9
are.
and 3 over 8.
All right. Yeah. So that's my lens makers formula. We'll keep a short class today, 45 minutes of class today. We'll extend the class in
Oh,
the next
okay.
class. Let me know what topic you want to do in the next class.
Next